Thanks for coming today. And thanks, Liz, for introducing me and for Kevin Johnson holding my hand for the last couple months getting ready. And it's just a real thrill to be here. And I appreciate you coming today on the last day and your patience and your willingness to come. I'm going to talk about science communication in a crisis. And I want to talk about it from the perspective of how a geoscientist may be involved when you have an acute event. There's a wildfire, maybe a train derailment or a pipeline explosion. They don't have to be this large, and they don't have to be international. There are times and places where a geoscientist can add clarity and content when the clock is ticking and things are going wrong. And responders, the folks who are charged to make this bad thing from getting worse, might be looking for some advice. The media might want an overview of what the biggest issues are. An elected official might be trying to see whether or not they can put any pressure on the system. And the public just wants to know, maybe because they're just curious, or maybe because the event is affecting their lives and livelihoods. Now today I'm going to talk for the next half an hour or so about communicating science. There is a perception that teaching and learning about communicating science is to avoid the metric system, not use jargon, avoid acronyms. Those are all nuts and bolts. Those are routes to maybe adding clarity. But that's not what science communication is about. Communicating science is about the transfer of knowledge to informing other folks and adding content. It is not about learning how to communicate science is more than just avoiding metric system and elevator speeches. Let me put it that way. I want to have some takeaways, and forgive me for being a geochemist. I should have written, geoscientists have a lot to offer. And I think that when we're thinking about adding science, scientific knowledge and content during a crisis, preparing, and I'll talk about this often, is enough. But it demands you to be a student again. But you can do it locally. You can start with your next door neighbor. But in order to do that, you're going to have to start to respect and understand the other players who are going to be involved. And I'm not going to go too much into detail about what this means, but you can't exchange a business card during a crisis. And whenever you get involved, if you happen to get involved, you want to strive for positive outcomes. How can you make your interaction beneficial? Suppose you're sitting on the plane tonight or tomorrow, and the person sits next to you and says, "Were you here for the convention, the Democratic National Convention?" You're like, no, I'm not. What do you do? Now, suppose that happened to me. I could say, I'm a chemist. Because in reality, I think I am a chemist. I think that I am a chemist. My laboratory is the ocean. Now, if I say to that person who's sitting next to me, I'm a chemist, many times their nose is going to crinkle. They're going to say, oh, I almost burned down my 11th grade class in chemistry. And they shake, and they're doing that for two reasons. One, it might actually have been a bad memory. And two, they're kind of signaling to you that, that this isn't their world, and they're uncomfortable about it. My title at Woods Oceanographic is senior scientist. So I could call myself a scientist to this person who's wanting to know about me. Scientist is a hard thing for a lot of folks to understand. It's just something that they just can't wrap their arms around. What is a scientist and what does a scientist do? And unfortunately, the default is the stereotype of the last pick in gym class, the nerd, the glasses that are broken and the misheveled look upon them. And so I don't use scientists that often. So chemist doesn't really work well. Now, I'm sitting next to this person. Chemist doesn't work well. Scientist is hard. Now, I work at an oceanographic institution, and my PhD is in oceanography. And if I said I'm an oceanographer, that same person who did not want to talk about chemistry, who could not understand what a scientist was, goes, oh my God, I love the ocean. It's the most favorite part of my life. And then she turns to her husband who's behind her and says, oh my God, this guy is an oceanographer. She's the same person whose nose crinkled when I told her I was a chemist. So what happened? Well, I'm lucky to be an oceanographer, right? But what really happened is that I found a shared interest. We connected. Now, we connected upon her memories, maybe of spending the summer on the beach every summer at her grandmother's house. But there was a connection. And those are the things that we have to keep in mind, that when we as scientists leave academia, the ivory tower, that we want to strive to find common interests. These interests don't have to be what favorite science they are. It might be that you're neighbors. It may be that you went to the same undergraduate school. Maybe you enjoy the same sports or worship at the same church. As scientists, when we want to have the most effective outcome, we should try to have some way of connecting with people. Now, what you don't want to do, on top of what I just said, is to then say, I'm a geochemist, I'm an earth scientist, and a chemical oceanographer. That makes it worse. And here's the reason why. You've added detail that doesn't need to be added. Right? As scientists, we always want to keep adding more detail. We want to add more detail. But in reality, you do not have to tell somebody on the plane who's just curious what you do that you're a geochemist or an earth scientist or a chemical oceanographer. In many respects, it even steps back from the oceanography as it is. So, and this is a challenge for scientists. It's a huge challenge when we leave the ivory tower about how much information we provide. So Liz talked a little bit about what I've been researching in my career, and I tend to think that a pollution event is putting nature on a treadmill. You know, if you go to your physical and you go to the doctor puts you on the treadmill and is checking to see how you're doing. And I find every pollution event a stress test. And I want to know how nature responds to this uninvited guest. There's a lot of opportunities to learn from basic science when we perturb a system. Of course, there's a lot of applied outcomes too about whether or not our knowledge can help in any type of pressing issue, whether it's short or long term. And because of the nature of my work studying oil spills and other types of pollution events, I have been working on oil spills throughout my career. I'm going to show you just a couple of them. I cut my teeth when I was in graduate school at the University of Rhode Island on this North Cape oil spill. And a couple of years later, I spent a lot of time studying this other oil spill from a barge called the Bouchard 120. And then I went back and started studying this old oil spill that happened in 1969. And then I spent a lot of time in San Francisco Bay when this cargo ship hit the Bay Bridge. And then I spent about 8 years studying the Deepwater Horizon disaster in the Gulf of Mexico, in which I learned a lot about how science works and how we communicate science. Now, a lot of you folks might be hearing me talk, and you say, I don't study oil spills, and I'm never going to be involved in a crisis. I can leave now. But what I've learned, especially during Deepwater Horizon, is pretty transferable to most geoscientists, so hang in there with me. I helped out the Russians recently. In 2020, they had a diesel fuel spill, in part due to destabilizing the Earth from climate change. It was an oil spill off the coast of Mauritius from a cargo ship, 2020. It was an absolute terrible event off the coast of Sri Lanka in which the ship caught on fire and lost a lot of plastic pellets and also oil. I just showed you a bunch of pictures of boats in oil and some type of unfortunate looking instance, and you might be saying, he just showed me 7 of the same pictures. In reality, as you know, that earth science and how things work is a lot like buying a house. It's location, 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 right? That where something happens is driven by the location and what the outcome is. But there's more to just the location. There's the type of oil that got spilled and the tides and all these other players. But there's more to that. And when I sit back and I've watched how, not only these, but other events, how do these events play out? And what happens? Well, what happens is that when you have a crisis, an environmental crisis, or any crisis in part, you suddenly are merging together and there's a machine being built. And there's a whole series of gears that are suddenly being slapped together and being expected to work. The big gear is the responder. Those are the folks who are asked to make this bad thing from getting worse. In the United States, it might be, if there was an oil spill, it might be the Coast Guard, or the United States Geological Survey, or the EPA. They're the ones asked, lead this, make this bad thing from getting worse. Of course, you have the media who wants to cover this. You have government officials or elected officials. You have the public who may be impacted or just curious. And you have academia who could possibly play a role as scientists. And you have business as well. Now, often we see the business and we think the company that was responsible for the spill or the event. But you have these other businesses. In Mauritius, Mauritius is a country that makes a significant amount of their money on tourism. The cargo ship leaked the oil, but another industry was very interested about what the events were going to play out because it touched upon their lives and livelihoods. When you look back and you see how these events played out, you can learn that there were some successful outcomes. And what drove a lot of those successful outcomes? When did these pieces of machinery mesh the best? They often mesh the best, or even maybe within a system. They mesh the best when the two sets of gears, or whoever's involved, understands the culture of each one of those gears. That they understand the value system and what matters. Right? The public gear has a very different interest in what matters to them than the responder gear. What they call success, what means to them about how successful the outcome is going to be. It comes down, more often than not, to time and interest and stakes. I wrote this up there. I want to make sure it's in there. Communicating science is more than avoiding jargon. It's about knowing your audience is heterogeneous and appreciating their value system. Let's do a comparison. In academia, it takes about a decade, maybe somewhere, from you to finish your PhD and maybe get tenure. We live in the world of years to decades. We strive to educate and learn, and we want to get tenure or other successful outcomes. So we are in the timescales of years. Traditional media might be assigned a story at 10 o'clock in the morning and expected to have 800 words by 6 p.m. And they want to inform the public, and that newspaper wants to sell ads. The responders are working immediately. They want to go home safe, and they want to make a bad thing from getting worse. Understanding who you're interacting with, when they say know your audience, knowing your audience means knowing what they want and what they need to know and what they consider important to them. And as scientists, when we're asked questions by non-scientists, you want to start thinking about what matters to them. Now, the stakes are very different. Now, let's go back to maybe a pipeline leak or an explosion where we have significant amounts of natural gas or methane being leaked into a nearby water system. Let's talk about the value and the interest and the types of things that are crossing somebody's mind. The public, there might be a person who lives 10 kilometers away from that event, and they want to know whether or not they can walk their dog in 3 days. They want to say, is there a scientist out there that can tell me that I can walk my dog on Saturday? there's a responding group out there who has never worked on a methane leak. And they're starting to say, well, how do we measure it? And is there any way we could have sensors out in a couple hours? And we don't care whether or not the precision is less than 0.1%. We want to know where it is and where it isn't. And so they need something fast. They're trying to figure out how to solve this problem. And we as academics might say, if we could collect enough samples, this might be a PhD project. So we got 3 days, instantaneous, in 5 years. But there's even more to that. The person who's walking the dog does not have to walk their dog on that beach. They could drive across town and not even be close to the methane. So it doesn't really matter too much, right? We have 9 million ideas about potential PhD projects. Does it matter to us? No. But that responder needs to know how to measure methane. So the stakes are higher. Understanding what people want, what it matters to them, and what they call success will lead to positive outcomes. Let's talk about some of the challenges that as scientists, when we have to communicate, and especially during a crisis, what are the challenges that we face? And then I'm going to finish off with some of the things, how we can overcome them. Let's talk about these challenges. Challenges for actually all those gears. The best way to explain it is from what Commandant Thad Allen, he was Admiral for the United States Coast Guard, and he said this: don't exchange business cards at a crisis. Often, when you have that series of gears put together, nobody knows who's who. Nobody knows what they do and what their value system is. Maybe you're all in a conference room and you're trying to figure out who's in charge and what's their background and what's their, who's their boss? How long have they been in this job? Who's in charge? And he said, Commandant Allen, he said, you shouldn't exchange business cards at a crisis. What he meant was that when the clock is ticking and things are going sideways and fires are burning or oil is leaking or a power plant is having a big problem, that is not the time to try to figure out who's who. So having an understanding of who's who is often a challenge for us in academia. There's a level of, comes back to detail. The public is watching something on TV, or even the media is covering it, and they see maybe it's some type of, maybe a radioactive spill, or something where there's a release into a water body. And they're going, why are they making this so complicated? Isn't this just like a bure adding liquid into a round bottom flask? It's so simple. Just shut it off, and everything's going to go away. Well, we know as geoscientists, earth scientists, that when you put Mother Nature into the mix, it is never easy. Mother Nature is a fickle beast. She does not play fair. And so we also know that there are other stressors in play. And so for scientists, this is really hard for us because somebody might be asking for our input. And we have to figure out a way to show them that it's not easy. Don't want to make it too hard. And this isn't dumbing down. I don't like that statement at all. This is about recognizing how much detail do folks need. Science has had some tough times from perception in the last decade. Let's say even say the last 5 years. But let's say the last 15 years. Tongue in cheek, I blame Steve Jobs. He's the fault for why science sometimes has a lot of challenges right now. Because he got damn iPhones out. So let's go back, and somebody takes out their iPhone, they're sitting at lunch, and they go, how many people were at the DNC convention last night? And they type into the Wikipedia, and they find out it was 19,442. They get their answer in 4 seconds. They understand what the answer is. They got the number. They understand that it seems reasonable. They have a sense of scale, right? If that came back 2, they would say, oh, it's got to be more than 2. I saw it on TV. And if it came back 2 million, you would say, it can't be 2 million because there's no way they could house all those people. So they have a sense of understanding the scale and whether or not what it means. And they also want it to be certain. They don't want it to change, right? So iPhones have taught society and given us an expectation that when you have a question that matters to you, you're going to get the answer in 4 seconds. It's going to be understandable. It's not going to change. And then you move on. That's not science, right? Science really will give you an answer with such certainty, so exquisitely understandable, and so certain that can all be comprehended in 4 seconds. Science is not built in a day. It's not built for speed. If science was a sport, it would be baseball. And we live in a world where everybody wants race car driving or soccer, where it's immediately clear, it moves a lot faster, you don't have all these crazy arcane rules. Science is slow. We should not be apologizing that science is slow. In fact, we should be reminding people that the scientific process and how we move about and solve problems is a great thing. And that's one of our challenges as scientists. As you leave the room today, we should be no longer apologizing for how science works. And maybe you're not getting a concrete answer in 4 seconds. No, you tell people that that's a good thing, that we're on a trajectory of learning more and more, and we move methodically and thoughtfully. Kind of touching upon this earlier, but I'm going to keep returning to it, especially during a crisis, a fast-moving one. The uncertainty is incredibly large. See what happened during the COVID response. And with time, like with science, our certainty improves. We live in a society that eschews uncertainty, and we as scientists are scientists because we embrace uncertainty. So we have to be mindful about the tolerance of our non-scientists towards certainty. We bathe in it, they run from it, uncertainty. This is a bigger issue, maybe on more slower moving crises, but it's vaccinations, climate change. I'm not touching upon climate change because I think communicating science with climate change is so much harder and so much more tricky. So think about this as kind of a primer. You'll hear about maybe some anti-vaccination person who might recite a paper that got published in 1963 in the Journal of Legos and wooden blocks. And they will say that that paper said that the vaccine was only 50% effective, or some number. And there is a perception in society that because one research paper out of 10,000 suggests a non-ideal outcome, or maybe a little bit less than everybody else, then science falls down. That science is a house of cards. That's just undeniably false. And this is a huge challenge for us as scientists, that we are dealing with folks who believe that science is more of a house of cards. And we should strive to remind scientists that it's not a house of cards, it is a beautiful jigsaw puzzle, that we are spending our careers and the funding to constantly be putting these pieces in place as we move forward, making a prettier and prettier, more resolved image. We're painting a picture of what we know. How do we try to do this? It's not easy. But science has a much better track record than politics or the media or the stock market or anything else. We're incremental, we're self-correcting. We have a much better track record, and we have to kind of push that through. So how do we move forward? Suppose you came here, maybe you say, well, I'd like to be more involved. I'm curious about how do you move forward. Well, the first thing is, before you do any type of activity, you have to look at the risk versus the reward. if you answer a phone call from a reporter and you get interviewed, is it worth it to you? You should be asking that. In the United States, a Coast Guard officer calls you and wants to talk to you about how do you measure iron, and they're looking for 15 minutes of advice. Is it worth it to you? Is it worth it to you personally? Is it worth it to you in your career? Now, in the United States, and forgive me for using the United States so often, there is no currency for public engagement. What that means is that there's an expectation for us to do this in our federally funded research projects, so we have some type of broader impacts. But there's no recognition that doing one engagement is worth more than the other. And we never put in the risk. Speaking to the student-run radio show at your local university has a lot less risk than being on NPR. You have to sit back and see, is it worth it to you? And speak to maybe your department administrator. Is this worth it to you? Now, I'm going to tell you that you shouldn't worry about whether or not this affects your resume or your CV. That often when you can make a positive benefit, you'll feel good about yourself. And we live in a world where we have a lot of rejection as scientists, right? It's hard. Papers getting constantly rejected, and our proposals are having a hard time. And suddenly your next door neighbor is asking you a question about science that touches upon them, and you can add clarity to them. Now, that's a low-risk question and a great reward, because you just helped out your next door neighbor. I'm driving home something here often is that often we think about communicating science as some huge thing that you have to do this at a national scale, and you have to think about whether or not this is all about TV and stuff like that. No. As scientists, we have a great opportunity to communicate to our next door neighbors and our friends and our relatives and places where it's safer and the risk is low. And the opportunities to learn from these experiences, improve, are better. Few people are ever going to testify in front of Congress, but a lot of us are going to be at dinner and asked about something in current events. Forgive me again, I'm going back to the Deepwater Horizon disaster, but there was a lot of lessons learned. And Jane Luchenko, who was then the administrator for NOAA, had said that the academic scientists that had a pre-existing relationship with the response community or with some of the federal agencies had the greatest success. What they were saying was that the scientists who might have known the NOAA scientists or the federal scientists and had a pre-existing relationship or just knew each other, that was a better outcome. There was a better chance that there was going to be a successful transfer of science that would lead to a meaningful, positive outcome. Pre-existing relationships are things that we want to strive for. So how do you do that? Again, you don't have to worry about, again, if you're in the United States, you don't have to fly down to Washington, D.C. and try to meet some elected official. No. If you want to understand the different cultures and what matters to different people and what their jobs are, you can start local. And be aware of what are the local issues? What are the issues at stake that may affect your lives and the other people's lives and livelihoods? Maybe you have a sewage treatment plant that might have to be replaced. What are the issues at stake? Who's involved? Be aware of who's involved. Who's leading to make decisions? And then meet them and invite them and exchange with them. Bring them to your lab group meetings. Bring the local reporter who handles science. Have them invite to your lab group or to your department. Don't tell them to list all the things that aggravate them about scientists. You bring a lot of reporters, they're going to say, oh, you guys never give us the right answer, blah, 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 blah. No. Bring different stakeholders to your department, to your group meeting, and ask them what their job is. And ask them how science could help them or what they don't understand about science. And then here's the kicker. You tell them how science works. These opportunities when you meet non-scientists are your chance to tell them that science is slow, but that's good. That science isn't a house of cards. It's this beautiful jigsaw puzzle. When you exchange, it's not about listing our gripes and aggravations with them. It's about understanding what matters to each other and exchanging those business cards when there isn't a crisis. And I believe, in my experience in 20 years, I have found out that you do not have to have a $2 million research lab and publish 10 papers a year and all these other attributes to be smart. There's a lot of smart folks in the media. There's a lot of folks who might have just graduated from the high school who are part of the response community. Just because you don't have a lab, and just because you don't have a PhD, and just because you didn't postdoc with so-and-so, does not mean that they're not smart or that their job is not important. You will find out when you meet and exchange with people that there's a lot of talented folks out there. We often hear too much about the negative. There's a lot of interesting, talented people that might be interested in what you do, and you're going to find out that you're going to have a greater respect with them. You don't have to be friends with them. You don't necessarily have to agree with them, but you should understand what their job is, and you can do that by starting locally. This sounds so ridiculously simple, but it happens a lot. A reporter might call a scientist and say, I'd like to interview you at 1 o'clock today. And maybe you speak to your media officer and you say, I'm ready, I'm ready. But you never sit back and say, what's the successful outcome? How would I, being interviewed, make this positive? It seems so obvious, but when we leave academia, we don't have the sense of awareness about what is success. And so it is perfectly fine when you're leaving academia, you're being asked by somebody else as a non-scientist, you could say, before you start talking with them, what would you consider success when you talk to me? It seems so simple, but asking these questions first lowers the tension and actually helps you. Kind of going back to your lab group meetings, your department meetings, maybe you have coffee with 3 or 4 people every day, and why can't you discuss current events? Why? These are great opportunities. Let's say there's some unfortunate crisis playing out in the Western Pacific, for whatever reason, and you're seeing it on the news, and you're learning and hearing about the news. Why? These are such great opportunities for you to talk with your students. Oh, maybe you study methane and there's a methane leak. You start talking about that in your lab group meetings. I wonder how fast you could measure that. How would you do it? Could we get a ship out there fast enough? My point is that there are teachable moments when these events happen that you have nothing to do with them, but you can look at them. You can create dialogue with your lab group members or the students and learn from them. There's a lot of us who may never, ever be called for ask during a crisis, but that doesn't mean that you don't have to get prepared. And one great way to be prepared is to start to have conversations with your colleagues about what would you do? And then maybe say, what do you think is the most interesting aspect of this if I was from the media? Now, a little earlier, I said something like, I'm not going to talk about the nuts and bolts of communicating science. I'm not going to talk about how to master the interview, but I'm going to do it once. Sorry, I forgot to wear my belt. This happens a lot on radio. There's a hot topic, and they bring on an expert scientist. And the reporter, or the journalist, starts to say, well, this afternoon, we have this pressing issue, ABC. And by chance, we have the world's expert in ABC. And this scientist has done this, and has done this, and is in the National Academy of this, and they've been in this, and they've published 9 gazillion papers, and their H factor is infinity, and they see all these things. And they have told their audience that you are the smartest, most talented person on that topic. And then the reporter asks you a question, and it's the easiest question. It's a softball, the easiest question. And you stop for a second, and you're getting ready to answer, and you start off with, well, we don't know this, and we don't know that. And there was a paper that came out last year by Victor Goldschmidt that said this, and Carl Tarikian's paper from last year said that, and there's a lot of things that we don't know. Now that's perfectly fine maybe when you're having a group discussion about all the things that you don't know. But those types of answers are the spreading zones for misinformation and myth. Because the person who's sitting at home is going, oh my gosh, that person who's the world's expert just said, we don't know, and I don't know. So when people ask you about your input and your advice, start with what you know. We know so much, and we always start with the negative. Be positive. Tell people what you know and what you don't know, what's changing, what's under debate, what might be happening in the near future, what are the things that we're worried about. But don't ever start with, these are the problems that we're having. It leaves an audience hungry and confused, and again, is a breeding ground for misinformation. If you're curious about this, you can read my book. Writing a book is, if any of you folks have ever written a book, or you plan to write a book is hard. Promoting a book is the most shameless, gut-wrenching, anxiety-ridden thing you've ever done in your whole life, because you're constantly saying, will you read my book? Will you buy my book? If you bought it on Amazon, could you give me a review? It's awful. It's awful. I mean, I'm so happy I wrote this book, and I'm so happy I could share a lot of my ideas in that book in here. But when you write a research paper the day it gets published, you put it on your resume and you might update ResearchGate and you might forward it to a couple colleagues and you're done. The day your book gets published is the day in which you actually have to start working. So I'm working right now, and you can buy it online, and if you happen to buy it, let me know. And just as a follow-up, if you like these slides, let me know. I will give them to you. You can use them anywhere you want. It's fine with me. If they send me emails afterwards. If you like it or dislike it, let me know. I know a lot of you folks have classes. If you would like me to be a guest lecturer on Zoom, let me do it. I'll do it. I'll go to an opening of an envelope to talk about this. So just again, as a takeaway, forgive me, I have geochemists here. Geoscientists have a lot to offer. And more often than not, just preparing and knowing how to do it, if you were asked, is more than enough. But it demands you to be a student. You have to start thinking about stuff that you haven't thought about or ever wanted to talk about. But if you do and you want to get involved, start local. Search for opportunities that are low risk, high reward, and easy. You're going to have to find out that a lot of these people, you're going to start to respect and understand them. Again, you want to start developing pre-existing relationships, or at least know who they are. And you always want to strive for positive outcomes. So I'm going to end right there. I'm glad to take any questions. Again, if I don't answer any of your questions now, send me an email. You can find me. Always happy to talk about this. Thank you.
Thank you. Oh, my mic's off.
Oh.
Thank you, Chris. And I wanted to tell people, I want to tell people, if you want to ask a question, please come up to the microphone, and so that everyone else can hear you. And while people are coming up to the microphone, I'm still going to lean into Chris, and I'm going to say, when I get asked on a plane what I do, I always say oceanographer for exactly the same reason.
No flies on your list.
Any questions?
Nobody. It's lunchtime. I failed.
No.
I never joke.
Hi, great talk. Really enjoyed that. I am going to ask you to maybe describe why climate change communication and science is a little bit more challenging. Maybe just touch on a couple things there. Thank you.
Okay. All right. Do not look at your watch. Do not look at your phone. In Fahrenheit, what is the temperature of this room? Did you say 40? 70. What else? Anybody? 68, 71. Let's say it's 70 plus or minus 3 for fun. What are all the new models talking about in which how the climate change is going to affect the Earth's temperature? They often talk about a couple degrees, 3-degree change. I think amongst many of the challenges, besides so many, that when we're describing the problem in this case that the temperature is going to rise by 3 degrees, and the lay public has a difficult time predicting what the difference in 3 degrees is, it's a big challenge, right? It's inconvenient, and it's a big challenge. You know, I work plastic pollution. I don't think plastic pollution is even remotely as big of a threat to the ocean as climate change. I think it's an interesting research project. I think there's a lot of room to making things better relatively quickly. But plastic is, you can see it. You can touch it, right? And you're visually arrested by the bird who's choking on a plastic bag. CO2 is colorless. 400 parts per million, what does that mean to the lay public? Right? We don't see it. It's such a slow-moving event that it's hard to arrest us and grab our interest. And that is one of many others. The other thing is, I don't know jack about climate change. So that's my other problem. But thanks for your question. Oh, we got somebody over here. This is good.
I'll bite. So thank you for your talk. That was really wonderful in describing sort of the proactive way that you can go out and engage with these other camps. I have experienced the opposite, where maybe those camps encounter your scientific work and represent that in ways that may or may not be positive or true. So do you have any thoughts or tips on sort of the more antagonistic relationships with sometimes the media and these other stakeholders who are either, you know, purposefully or not, misrepresenting the scientific side of what we actually do for a living?
It's hard, right? It's hard to debate and try to fight back on science in that respect. There are difficult conversations sometimes at dinner time with the crazy uncle, right, who says that the earth is flat. And what do?
I'm from Missouri.
Might be crazy uncles. I'm going to say something that might frustrate a lot of you folks. It is perfectly fine to walk away. But you come back. And I think the power of email and follow-up is where you win. I think person-to-person confrontations never win for scientists. I think that we have too high of ideal, and I think we play too fair, and we do things the right way. But I do think that when you have an opportunity to educate somebody or maybe give them better information, I think email is a great way, because you can craft in a way that's thoughtful and careful, provide the information to them in a way that's non-threatening. And I'm going to tell you what, you're going to build, a lot of those folks are going to maybe build some trust because you took the time to follow up. There is a good thing though. It's good to learn why people have certain ideals. And they're not dumb, they're not stupid. It's just that they're getting an information from someplace else. And it's good for us to find out where they're getting their information. But I do think it's not easy, you know. But thank you for the question. I'm sorry, I can't see, the light is like right there, so I'm trying to see your face.
Hello.
And then, yes.
Okay, so I have a question because, so I'm a grad student, and say when people hear that you're a grad student in the sciences, and I'll have to think about, like, you know, explaining what I do in like your oceanographer way. And then they hear that, and then they ask you about something, and you really don't know because you don't know all of science. But like, yeah, how do you suggest approaching those conversations?
In a very similar way that I just answered the last question. There's nothing wrong with saying, I don't know.
But you're like, don't lead with it? Is that?
Yeah.
Okay.
I mean, yes, right? I just told you otherwise. I think that I think that it is perfectly fine for you to say, I spend day and night studying the geochronology, how old the Earth is in this certain area, right? Your question is pretty far bound from what I think about. But I'll tell you what, my next door office mate thinks about that problem all the time. Let me get back to you. Again, I think that these opportunities where maybe you can't give them the answer at that same time, but following up is meaningful.
Okay.
It's
Thank
frustrating that you don't have the answer, but you try your best. We're 25 seconds past our time. Oh, good. Come on.
Hi.
Questions. Somebody annoyed with me? Come on.
Hi.
Oh, hi.
Thanks
Hi,
for your
Carolina.
talk.
Yes, hi.
So I see you highlighted mostly the individual actions, right?
Yeah.
That scientists can have.
Yeah.
So like thinking on the institutional community opportunities that like our scientific community have, what do you have to say about that? Like what would you highlight, which is like the best approach you would suggest?
Well, for the Goldschmidt meeting, I think it would be pretty interesting to have somebody who is part of one of those gears who often has to think and think about science, right? And so we have opportunities on this scale to engage and exchange and inform. I think for me, on kind of an institutional level, mine is to, and again, forgive me, I'm from the United States, so we're somewhat US-centric, not somewhat. Academic administration fails to recognize the risk versus the reward. There are certain entities that want you to be more out, they want you to be in the Wall Street Journal, but then they're devastated when you have a poor quote, right? And so if you're gonna support us, support us. If you're not gonna support us, don't support us. And then create some type of metric that is meaningful for us. And in reality, we live in this gray area of, is public engagement good? Is it bad? If I do a bad job, am I in big trouble? Suppose I have a really good interview on NPR. What does that get me in my career? And so I would really press upon, from an academic administration perspective, to support us and provide a little bit better currency. Is that it? Oh, we owe more. Awesome.
Hello. I think that high-temperature geochemists have a very hard time seeing themselves as first responders of something that's happening.
Yep.
Unless you like work with like volcanic forecast eruptions or something like that. And I think that makes us very detached to this like surface processes that are happening. Can you comment on like how can we close that gap so we are like more in tune with like what the other geosciences are doing?
I think that you probably have a lot of overlapping interests. I just don't think that we've probably thought about it that much. Or maybe we need to exchange with other people. I think geoscientists can interject and add content in just about every problem we have in many respects. We just have to figure out what there is. But the key point is, at this point in day and time, for most of us in academia, we don't have to do it if it's not working for us. But these exercises about maybe meeting and talking to maybe a local reporter or speaking to the water quality administrator in your town, these are valuable opportunities to understand how the world works. Quite frankly, science as a whole would do a lot better if we knew a little bit more about current events.
Yeah, I think it would benefit the field as a whole because at the end we do go to these volcanoes to sample rocks that are in the surface, and it's a land, and that land is from someone, and that land has a history. So I think like I really like your talk because it makes us think, what are we doing to be more conscious about where these rocks are coming from, even though we're using them to study things that are happening very deep. Yeah. We cannot lose that connection with, we're still humans and social creatures. Thank you.
No, it's true, but I have to remind you again that from, at least in the United States system, your role in public engagement as a whole does not have a lot of weight. And so whether or not you get involved, whether or not you answer a phone call, look very closely at the risk versus the reward. And more often than not, look to whether or not how it helps you as a person and not how it helps your resume. But these are tricky times. You don't have to do any of this stuff. If you want, I gave you a little bit of a roadmap. Thank you. Thank you.